Okay, so we're recording now, and we'll go ahead and get started. Okay, so again, most of the quizzes are okay. I don't think I have to go over the quiz because almost everybody got the full 5 out of 5. So good, keep it up on quizzes. We're not having a quiz this week because we're having a test. And so again, in general, every week will either be a quiz or a test. So, quiz, but exam, quiz, exam, and so on. Right? In my opinion, the quizzes are pretty easy to get full credit. If you make a mistake, just ask your teammates about it and just get it right. So you've got 2 or 3 other people to help you to get it right. Okay? And I email you back your score. Hopefully you got it and everything's fine and dandy. Okay, but this week we're having a test. Now, most likely I'm going to finish 1.5 either today or tomorrow. Might even finish today, but that's okay. And again, buffer day doesn't mean it's a holiday. I'm just going to go ahead and get started with chapter 2. So most likely I'll do 2.1 tomorrow, Wednesday. Okay, Thursday again, I will reserve for questions and answers. So if you have any questions about any of this stuff, of which I'm mostly done, and I'm getting it for 1.5, then bring it up on Thursday. If you don't ask me questions, then I'll just keep going with chapter 2. Okay, so I might be going on to 2.1, 2.2. Anything I do on chapter 2, however, will not be on this Friday's test. This Friday's test will cover just this stuff. And again, this is when you turn in the homework. So some of you already gave me part of the homework. I don't need the homework every day. I don't even need it every week. Okay, I just need it every test. So everything here, 1.1, 2, 3, 4, and 5, you submit the whole thing on Friday. Now, if you want to turn it in early, I'll let you. So let's make it so I don't get it all confused. You may turn it in as early as right after class on Thursday. Oops, I'm pointing at the wrong day. Thursday is February the 4th. Oh, it's already February, believe it or not. So February the 4th, after class at what, 10 o'clock, I'll take the homework. But the latest I'll accept the homework is in half an hour after the exam. Okay, so if you have any questions, bring it up on Thursday the 4th. Friday again is our exam. We're not going to do anything else. There's no lecture, no questions and answers. If you have any questions, bring it up on Thursday or see me in office hours. So our class starts at like 9:10, right? So maybe 9:01, 9:02 on Canvas announcements, the same place where I put the videos, right? I put the videos every day after class, after an hour or two when it's all finished. Then I put it on Canvas. On Canvas announcements, I will put the exam. You open it up, then you just get started on the test. Okay, you have to have your camera on. By the way, I'll take attendance, so I'll know if you turn in a test and I don't see you, then I'm going to say, well, you probably just didn't want to show your face, so that means you cheated, right? That's going to be my assumption. Okay, so I will take attendance. I'm not going to call the roll. I will just silently do it. I guess the best way to think of it is what happens when you have a test. If we were meeting face to face on campus, right? I wouldn't call the row. I would just easily look at everybody. I get the whole hour to figure out who's here and who's not, right? And so during the test, that's all that's going to happen. You take the whole time for the test. Keep yourself muted, but have your full camera on. So I insist that you have to have your camera on and the true background behind you. So no Golden Gate Bridge or anything like that behind you, but the actual background. During the test, if you have any questions, then send it through the chat. Please don't unmute yourself. Again, think of what happens if we meet face to face. If we meet face to face on an exam, I wouldn't want you to just blurt out, hey, how do you do number 7, and disturb everyone else, right? So ask me via the chat. That's kind of the equivalent of, coming up and ask me, person to person and just whisper what your question is, right? So we're just thinking of equivalence. What happens if we met face to face and so on. So don't unmute yourself during the test. Just send me a question via the chat. Okay, then at 10 o'clock, the test will end. I will close the session. And by the way, if you finish early, you can leave early and just email me. And you know how to email me. You've already done it twice with the quizzes. So do the same thing for the homework. Do the same thing for the test, right? So just get your cell phone, click, 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 click. Take pictures of all your test problems. Show me all your work. Okay. By the way, if you're in doubt as to how much work to show, do what the teacher does, right? I mean, it's always a good idea. I mean, not just for me. It's a good idea for all of your classes to do what the teacher does, right? So if I show you, okay, show me this step, you should do likewise on the test, right? And then I'll close the class as usual at 10 o'clock. You have 5 minutes to submit to me your test, email me your answers, and then I'll give you another half an hour, so until 10:30. So 10:30 a.m. you must submit your homework. But again, if you want to submit it early, you may submit it early. By the way, if you have a scanning ability, go ahead and scan. Scanning usually comes out nicer than just click, 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 as a lot of you know, comes out nicer. Okay. Reminder for the homework, I've had students before tell me it doesn't all fit because, you know, this, everything here, right, is much, much longer than a test. So it may not all fit. I know sometimes when you email, there's like storage limitations, and it might say, oh, I can't, the email might say, I can't send the whole thing or break it up into more files. So if you want to do like 1.1 and then another email for 1.2, 1.3, or 1. And so on. So 5 emails is fine. Or maybe 1.1, 1.2, 1.3 will fit, and then 1.4 and 1.5 that'll fit, and you know that will work also. Okay. There is a homework requirement, a 70% homework requirement. Okay, I realize maybe you can't get all the questions, okay, but there's a 70% homework requirement. And remember, what do I end up doing? I end up doing half, you know, maybe a little bit more than half sometimes of all the problems anyway. So it's not that hard to have 70% of the homework. So if I don't get at least 70% of the homework, I don't grade your test. You get a 0. Okay. And by the way, I do make a little bit of a comparison between the handwriting on, you know, the homework and handwriting on a test. I'm not a handwriting expert, but you know, some things are obvious. So if the handwriting on the homework doesn't seem to match the handwriting on the test, then obviously I get suspicious, right? And that's a little bit part of my safeguard. Okay, I mean, it's fair. It might be easier for a student to get somebody to cheat for them on the test, but it's much harder for you to find the same person in the same handwriting that's willing to do all the homework for you, right? Because, you know, I'll look and see a comparison of the homework writing and the test writing. You know, it doesn't look like the same, then I get suspicious, right? So that's a little safeguard for me. So you might get somebody to cheat for you in the test, but you much less likely to somebody, you know, wants to do all that homework for you, right? Okay. So that's all that for the test. Anybody want to ask a quick question now before I get started with math? But any quick questions about the format of the test and so on? And I repeat myself. Yes, you say you already said all that. Yeah, repetition's good. Sometimes people don't get it all the time, or somebody was absent. I try to repeat so often that you shouldn't have any excuse as to know what's going on. So that's sort of that. Okay, then I'll go ahead and start with the math. All right, and I'll be giving you an in-class assignment today also, and again, it might involve exponents. So for exponents, remember you have the up caret, which is, I can't show it to you right now until I get into chat mode, but it's above the 6 on most keyboards. It's the up caret, sort of like an arrow up to make a exponent. So we want, let's say, e to the x power, then e, then up caret x. Is that right? Okay, so you might need that for today's in-class assignment. Okay, so all I have left, and I might finish it all today, was, I think it got up to roughly 47-ish. So 51 to 54, 63 to 69, 70, 71, 72. Okay, so some exponentials and some logs. So let me get those out of the way. Okay, again, I'll show you the even ones. So 52, the original problem was ln x squared minus 1 equals 3. All right, so if you have an equation that has an ln, to knock it out, you exponentiate. But the way you put it is a little bit funny. Okay, you have to bring the e sunken down into the left. So what I have in red is what you're supposed to write. Okay, so again, the original problem was ln blah, blah, blah equals 3. Get rid of an ln, you do an e. To get rid of an e, you do an ln. But you don't put the e in front. You don't divide by e. The e goes down and sunken like so. So this is the way you want to write it. Okay. All right. So again, anytime you have an e and an ln back to back, they cancel out. So now you have x squared minus 1 equals e cubed, and that's not so big a deal, right? Okay, so add 1. X squared equals e cubed plus 1, and then take the square root property. So x is plus or minus square root of e cubed plus 1, final answer. Okay, a quick reminder, you're only allowed to take logs of positive quantities, but if you were to plug this in, you're going to square it, and it's going to end up being positive, so that's fine. just a side note, so I'm just thinking out loud, what if you had to type this in the chat for the problem? So plus or minus, there's a plus symbol, right? There's a plus, then you can do a slash and a minus. So plus slash, so maybe if you would type it plus slash minus, like that, plus slash like the division and then minus. Square root, you can type squirt, and e cubed, you would go like this, e exponent 3. Okay, so that's how you would type it in the chat for later. Okay, so plus or minus like that. Squirt, I guess you have to put parentheses, right? Parentheses, e cubed plus 1 parentheses. So that's how you would type it, I suppose. Right? Plus or minus square root squirt e cubed plus 1. All right. Okay, B, e to the 2x minus e to the 3x plus 2. Now, this is a quadratic equation, actually. It's a quadratic in e to the x. You may notice that if you square e to the x, you get e to the 2x. In other words, it's e to the x quantity squared. So if I temporarily cover this up, see how that matches that, right? If you temporarily call it, say, y, then it looks like y squared minus 3y plus 2, right? So, oh yeah, I know how to factor that. Or z squared minus 3z plus 2. Or temporarily call it w squared minus 3w plus 2. Then you would go w, or y. So you can just go e to the x, e to the x. And then minus 1 and minus 2, right? And again, to double check, you would fold it back out. Let's do it. If you multiply it out, what's e to the x times e to the x? E to the 2x. You add the exponents. And then minus 2 e to the x minus another e to the x, that's minus 3 e to the x plus 2. So it works. Okay, so that means by the zero factor property, either that's 0 or that's 0. Okay. So e to the x minus 1 equals 0 means e to the x equals 1. E to the x minus 2 equals 0 means e to the x equals 2. And how do you get rid of an e? ln. Right? So take the natural log of both sides. So in a nutshell, if you have an ln, right, you get rid of it with an e. And if you have an e, you get rid of it with an ln. ln is not sunken down. It's put in front. And quick word about language. I know I'm not testing you on language, but you don't say multiply by ln. This is not a multiplication. You're applying a function. Okay? Or you take the natural log of both sides. It's technically not multiplying by ln. Okay? And again, once you put the ln, they cancel out. Okay? ln of 1 turns out to be 0. Okay? And ln e to the x, ln 2, you just leave it alone. So final answer, x equals 0 or x equals ln 2. And let's see, in terms of typing, yeah, you can type ln 2. That's no big deal, right? You can type an L on a keyboard and an N and a 2. Okay? So as I do these problems, I have to think of how you would type it on the computer, but this doesn't look like any problem. Okay. Okay, 54. The original says ln x equals 1. Okay, again, you might get dizzy with all the ln's, but just take them one at a time. So I say to myself, okay, cover this up. How do I get rid of this ln? With an e. So I exponentiate both sides. Again, it comes down and sunken. And I will grade you on how you write it. Okay, so if you put the e in front like this, or if you divide by e, that's incorrect. The e has to be sunken down to the left. If you want to put that in your cheat sheet, you may. Oh yeah, reminder for the test, you may have one formula sheet, regular size paper, 8.5 by 11, both sides. Okay, but other than that, you can't use anything else. You can't use the book, notes, people, internet, computer, etc. Right? Just the way it would normally be if we met face to face. All right, so that will cancel out, and I have e to the 1. But what's e to the 1? Just e. Okay. So now my equation looks like this, right? These guys cancel out. I have ln x equals e. So now how do I get rid of this ln? Same thing. Do another e. So that's the answer. X equals e to the e. What is its value? I don't know. You can put it in your calculator, but you don't have to. It's 2.718 raised to the 2.718, whatever that is. Okay. So the original had 2 ln's, so you need one e to knock this one out, and you need another e to knock this one out, right? So it's not as bad as you might think. Okay, I got ln. What if they give me ln? Well, I need E, right? Okay. Crude analogy, it's almost like a video game, right? There's 3 bad guys here. Well, I need one to knock out this bad guy and another one to knock out that bad guy, right? You just keep shooting your target or whatever till you get them all out, right? So you need one E to knock out that ln, and you need another E to knock out that ln, and there we go. Okay. All right, B is a little bit tougher. The original, ignore the red, e to the ax equals c e to the bx, and for some reason they say a is not equal to b. We don't know why yet, but we'll see shortly. And let me raise it up so you can see it a little bit. Whoops. And every now and then my camera turns yellow. I don't know why. Okay, solve for x. So first thing I notice is that you have x on both sides, so get them on the same side. So how about divide both sides by e to the bx? So divide both sides by e to the bx. That cancels out, so this side is just c. And what's e to the ax divided by e to the bx? Well, it's e to the ax minus bx. Okay, so right now, it looks like this. E to the ax minus bx equals c. How do I get rid of e? ln, right? So to get rid of an ln, you put an e. To get rid of an e, put an ln. So that way, the ln and e cancel out. Yeah, for those of you that like video games, you know, I got to get rid of the e. I knock out the e, you need an ln. And likewise, how do you knock out an ln? You got to apply an e. Right? They knock each other out. So now I have ax minus bx equals natural log of c. Again, ln stands for natural log or log natural. All right, then I just solve for x. So factor out the x parentheses a minus b, and then just divide both sides by a minus b, and we're done. So x equals natural log of c divided by a minus b. And now we know the reason why they say a cannot be equal to b, right? So can you see what happens if a and b are equal? Like suppose they're both 7. Then you're dividing by 0, and that's a mathematical no-no, right? So that's all. All right, so that's that. And the only thing we have left are a little bit of review of trig and inverse trig. So that's 63 to 69, 70, 71, 72. That's what we have. Okay, there's one thing in the chat. Let me see if I can get it. All right. Okay, somebody said something about an email. I'll try to get the email later. I can't get it now. Yeah, for the final answer, leave it as e to the e. That's okay. If it asks for a decimal approximation, then yeah, then go ahead and do it. Where'd my calculator go? So yeah, if it says give a calculator approximation to so many decimal points, then do it. Let me just do it for fun here. So e to the 1. My calculator needs to have an exponent, so I do e to the 1. 15.15426, whatever. 2.7 raised to 2.7. But I will accept just e to the e. In fact, I'll be stronger. You must have e to the e. Okay, so you're not allowed for me to only put 15.15. If I see e to the e and this, I'll take it. But you must show me at least e to the e. Okay. All right, so some trig now. And by the way, these should be done without a calculator. Okay, 63A. I don't think we had any evens here, did we? Except at the very end. Yeah, 63 to 69 odd, 70, 71, 72. Okay, so I'll show you the evens there. Inverse cosine of -1. Okay, I like to call it theta. So I'll label it as theta. And I'm guessing you don't like inverse cosine. You would rather do cosine. Me too. So rewrite it so it doesn't say inverse cosine, just cosine. So you just switch these around, right? Remember, for an inverse function, you just switch around x and y. So this says the same thing as cosine of theta equals -1. So cosine of what angle is -1? Okay, you want the x coordinate on a unit circle to be -1. Well, that's at 180 degrees or pi radians, right? So remember, the cosine controls the x-coordinate. Where's the x-coordinate -1? That's here. So where's here in standard position? 180 degrees or pi radians. Okay, and again, for now, unless we say otherwise, your answer should be in radians, not degrees. Right? So inverse cosine, I call it theta. No, unscramble it, write it without the -1 exponent. Okay, am I taking the cosine of -1? No, I'm taking the inverse cosine of -1. You must be taking the cosine of something else. The only other else is theta, so cosine of theta is -1. Okay, same thing, inverse sine of 0.5. Okay, so first call it theta. Okay, write the same thing without the -1, the inverse sign. I want sine. So what am I taking the sine of? Am I taking the sine of 0.5? No, that doesn't make sense, right? You're taking the inverse sine of 0.5. It can't mean the same thing. I must be taking the sine of something else. There's only one other else, theta. So sine of theta is 1/2. Okay, then you might recall from trig, that angle is pi over 6. Okay? Or if you wish, what I always do, and it helps me that you don't have to memorize it, is, okay, sine is controlled by the y-coordinate. I draw myself a unit circle. Okay? I go halfway up for y, and I go like that. And then I say to myself, what does that angle look like? 30 degrees, pi over 6, right? So if you can draw yourself the picture, to me, that saves you from having to memorize this all the time. Okay, say sine theta, oh yeah, y coordinate. So I go halfway up. Your picture doesn't even have to be that accurate. Okay, it would still work out. Go halfway up, go like that, and say, okay, what does that angle look like? It looks to me like it's 30 degrees, which in radians is pi over 6. Okay, then 65a, inverse cosecant. Okay, so there's two things here I don't like. I don't like the -1, and I don't like the cosecant. So we'll get rid of both of them. Okay, so inverse cosecant of radical 2. Call it theta. Unscramble it. Cosecant theta is radical 2. I don't even like cosecant. So I'll go in terms of the reciprocal. What's the reciprocal of the cosecant? The sine. You might recall one function has a co, the other does not have a co. Or since I'm allowing you the cheat sheet, if you want to put down the trig functions and the reciprocals, you may. But I remember cosecant, there's a co, right? So reciprocal does not have a co. Sine of theta is the reciprocal of radical 2, 1 over radical 2, which is radical 2 over 2. Okay. And then I remember, oh yeah, that's 45 degrees, right? That's a famous number from trig, radical 2 over 2. So theta is pi over 4. Okay, I do see something in the chat. Let me get to 67a and get this out of the way. Even harder, inverse cotangent of negative radical 3. A little bit harder. Turn my page on my book. Inverse cotangent of negative radical 3. Okay, call it theta. Unscramble it. Get rid of the -1. Cotangent of theta is negative radical 3. Now, cotangent is cosine over sine. So I'm going to write it as negative radical 3 divided by 1. And there's a trick to this one. The trick is to divide top and bottom by 2, like this. Why? Because it works. Okay, so just do it, and I'll show you what happens after that. Okay, now what you do is you set that equal to that, and that equal to that. Okay, so again, from inverse cotangent, I make it cotangent, switch them around, divide by 1, change cotangent to cosine over sine, and then divide by 2. So now I have to say to myself, cosine is negative radical 3 over 2, sine is 1/2. Oh, I know sine is 1/2. I go 1/2 unit up, but it's not first quadrant, it has to be second quadrant where the cosine is negative. Okay, and then I look over here, looks at me at the angle. This angle is 30 degrees. So in standard position, this angle is 150 degrees, or 5 pi over 6 in radians. Okay, so that's what I have right there. Okay, and let me check the chat. All right, let's see. Do we have to draw the unit circle? No, you don't have to. It helps me to draw it. Okay. And yeah, I mean, some of you already have it memorized. If you have everything memorized, it's fine and dandy. Okay. But let's say if you do show me the unit circle, sorry. If you do show me the unit circle and you get something wrong, I'm more willing to give you partial credit. I guess maybe that's the best way to say it. Okay. All right. Let's see. Somebody asked for 65b. I'll do it quickly. Arc sine of 1. You're saying the sine of what angle is 1? Okay. So 65b. Arc sine of 1. And by the way, arc sine and inverse sine mean exactly the same thing. Okay. So call it theta. And then I'm going to go sine of theta equals 1. Okay. Write it without the arc. Arc and inverse, you know, the -1 stuff, it means the same thing. This is easier to type. So like if you were to type it on your keyboard as an answer to me, it's a lot easier to type arc sine. It's less writing to do -1, but it's harder to put the -1 up there, right? Okay, so the sine of what angle, nice angle, is 1. I want the y coordinate to be 1. That's up here. Right? So where's here? Pi over 2. So theta equals pi over 2. Okay, let's see, looking at the time. Okay, I may not quite finish, but that's okay, because I want to give you a chance to do one of these on your own. Okay, the last few problems, and I'm done. So if I don't finish today, I got tomorrow, I got Wednesday, and so on. Okay, a little bit of remembrance of right triangle trigonometry. Okay, so do you recall this from your trig? I'll raise it up here so you can look at it and see the video later. Okay, so if you're given a right triangle, which means it's a right angle, here's a theta. This is considered the opposite side. This is the hypotenuse and the adjacent side. You've all seen that before, hopefully. And in case you're wondering, you might say, well, isn't this also adjacent? Yeah, but this already has a name, hypotenuse, right? So the adjacent side is the side next to the angle that isn't the hypotenuse, right? So it's very clear. We already have hypotenuse. So opposite, adjacent, hypotenuse. Okay, and then maybe you've heard of SOHCAHTOA from your trig. Okay, what's SOHCAHTOA? For those of you who've never heard of it, sine is opposite over hypotenuse. So the sine of theta is the opposite side divided by the hypotenuse, right? C-A-H, cosine of theta is adjacent over the hypotenuse. And TOA, tangent, you might recall, tangent of theta is the opposite divided by the adjacent, right? Okay, so the last few problems involve that. Okay, so 69. I'm going to approach 69 a little bit differently. It says, prove that cosine of inverse sine of x is square root of 1 minus x squared. Okay, really, I'm going to think of it like this. I'm going to work this out, and the back of the book is that. It's really the same thing. In fact, you almost have an advantage because they're already telling you this is the back of the book. Okay, so I'm going to approach it from the standpoint of saying, find cosine of inverse sine of x. Okay? And this is the answer. So find cosine of inverse sine of x. Okay, so my approach for this, and by the way, same approach for 70, 71, 72, which I may not get to today. Yeah, I think I'll stop after this one. Okay, is call this theta. See, I don't like cosine of this stuff. Say, I would much rather do cosine of theta, right? So just call this theta. So let theta be inverse sine of x. I'll raise it up. So that means ultimately I'm trying to find a cosine of theta now. I've changed the problem. Okay? So I say instead of doing cosine of that messy thing, I'll just call that temporarily theta. So I'm trying to find cosine of theta. So theta is inverse sine of x. Okay. Rewrite it without the -1. And if it says arc, same thing. Arc sine, same thing. So sine of theta, you know you're not taking the sine of x. You're taking the inverse sine of x. So what am I taking the sine of? Theta. Sine of theta is x. I'm going to write it as x over 1, so I can do my SOHCAHTOA. Okay. So sine, S-O-H, sine is opposite over hypotenuse. So I just make myself a little triangle here, put theta. The opposite I put down as x, and the hypotenuse I put as 1. Right? So, SOHCAHTOA, sine of theta is opposite over hypotenuse. So I go opposite, x, hypotenuse 1. Now figure out the adjacent side. Okay. If I temporarily call the thing behind my finger y, I have x squared plus y squared equals 1. Right? A little bit of simple algebra. Subtract x squared, take the square root. Y is radical 1 minus x squared. Is that right? So there's my triangle. Okay. So again, I call this theta. Theta is inverse sine of x. That means sine of theta is x, x over 1. Do my SOHCAHTOA, draw myself a triangle, opposite over hypotenuse. So x over 1. Do a little bit of a squared plus b squared equals c squared, and I get y equals radical 1 minus x squared. Okay. And now what am I trying to find? I'm trying to find cosine of theta. Okay. So cosine, SOHCAHTOA, cosine was adjacent over hypotenuse. So what's the adjacent over the hypotenuse? Radical 1 minus x squared, right? Divided by 1, which is just square root of 1 minus x squared. And that's what we were supposed to show. So radical 1 minus x squared. Okay, and problem 70 is like that, but I'll save that for tomorrow. And 72, the problems at the end are just about like that, but I'm going to stop right there. Okay, let me get from the chat something quickly. What lets you change sine inverse of x to theta? Okay. Well, in math, we're always allowed to substitute anytime we feel like it when you stop and think about it. Okay. I mean, if I have this thing, I'm allowed to call that thing w, right? If I felt easier about it. E to the x, I'm allowed to call that y. Okay. And so, yeah, anytime I wish to make the problem easier, you can make that substitution where to go. And just say, okay, I'm going to call that theta. And notice it worked, right? Everything fell into place once I made a substitution. And said, let me call that theta. Then, the wheels start turning, and I can figure the rest of it out. Okay. All right, so I'm going to stop there. I'll give you an in-class assignment. You can type your answer in the chat. I showed you how to do that. Okay. So right now, if you would, please, I want you to go back and do for me on page 67, 51, A and B. So I can't do too much for you. So 51, A and B. If you have the book, just look in the book. Otherwise, write it down or take a picture on your cell phone or do a screenshot because the book is heavy. I don't want to hold it too much longer. So how about I give you another 15, 20 seconds. 51A, 51B. Okay, type your answer in the chat and then you may leave. Okay, and a hint, of course, how do you get rid of an E? ln. How do you get rid of an ln? E. Okay, so 51A, 51B, put your answer in a chat, private chat, please. So, somebody can't just look at your answer and type it in. If you have a question, you can ask me or ask Prasanna. Okay, just a few more seconds. 51A, 51B, I'll even read it. E to the 7 minus 4x equals 6 is A. And B, natural log of 3x minus 10 equals 2. Okay, at this point, I'm not going to hold this book anymore because it's heavy. So I'm going to take the book down. Okay, so go ahead and work on that. I'll stop the share. I'll stop recording also, so we're no longer recording.